Good morning, good afternoon, good evening, wherever you're joining us today on this session. Our webinar today is going to be platform engineering, just a fad or the remedy of modern development headache. While we are still waiting for people to join, I wanted to cover a couple of housekeeping items before we kick off today. So the webinar will be recorded, so don't worry if you miss anything, and we will be sending the recording within like 24 hours. If you have any question regarding the webinar or further question post-events, you can always email us at webinars@jfrog.com. You can also ask your question using the Q&A and the chat button at the bottom of the screen. And also, as a reminder, don't be shy and use those buttons to ask all your questions. So I'm going to kick things off today, introducing our speakers. So Bill Manning, Solution Engineering Manager at JFrog. Bill, the floor is yours.
Thank you so much, Finette. I always appreciate you introducing me. It's always wonderful. Hey guys, thank you so much for joining us today. We're gonna have a good time. Basically, it's gonna be a lot of information around, what is it? What is platform engineering? How do you prepare for it? How do you plan for it? What are the benefits? All the usual stuff. And also, too, of course, we'll be seeding in some information around our platform, because actually, in my opinion, and in the opinion of a lot, over 7,000 global customers who utilize our platform, we kind of are the ideal situation, kind of the ideal platform. And if you read the guidelines when we go through it, you'll understand that the JFrog platform is really an excellent platform for platform engineering, right? So let's go ahead and kick this off. And here we go. So first of all, as you can see on my slide, I made the joke is, welcome to what is DevOps? And I meant that as a joke, actually, because what the question should be is, what is platform engineering? The thing is that in this day and age, that there is an ambiguity, right? This whole thing about 2 years ago with platform engineering suddenly became a topic of conversation with some of the first meetups happening in the US and in Germany, kind of discussing this. We'll go through some of the ideas that came about from this. But the thing is that, first of all, you should probably understand who I am. Right. So like I said, I'm William Manning. I am a solution architect here and also solution engineering manager. My job is to work with our customer base, new customers, existing customers, and come up with best ideal solutions on how to implement and use the JFrog platform. Everything from Artifactory for the management of artifacts, those third-party transitive dependencies, and the builds you create, how to make sure they're safe and secure using our X-Ray product. We've actually introduced some really amazing new features lately, like contextual analysis. I'll kind of tease you at the end. We at RSA next week. Come by and see me if you happen to be there. I'll be there all week. I'll also be demonstrating a lot of these new features and better ways for your companies to go out there and protect themselves. But you know what? Without further ado, let's just go jump right in, right? And to start off, we need to understand the software evolution development, right? Development of software development. Like, for me, I mean, just to kind of give you a raw idea, obviously I've got a lot of gray hair and white on my chin, but it didn't always look that way. Yes, this is scary. This is my 24-year-old self back in 1997 when I started. I think this picture was probably taken around 99, actually, because we were in our new office then, and also too, I had one of the first digital cameras that were like readily available on the market. You can tell from my StarTech and my G-Shock watch, I was ready to go and coding my heart out with my giant CRT. But the thing is that, before 2000 and we started getting into like the modern day development aspects, there was like waterfall in the 1970s, very linear processes, huge long cycles. That actually carried over even to my era of development when I started my job. You would start off, you would meet for 2 weeks, come up with feature stuff that would come from product. You would spend 6 weeks or so coding, another 2 weeks of sitting around and doing QA fixing and validation, and then you would release these giant monolithic quarterly releases. They were terrible. Like, let's just face it, right? I mean, the thing is that having to wait for updates for that long period of time were terrible. Then things kind of moved over to more of like an evaluation-based SDLC model, software development lifecycle model. That was more spiral. It didn't really catch on, but that was like an attempt in the late 80s, early 90s to do something like that. Then there was the RAD method, which I always thought was hilarious. Be like, oh, that's rad, dude. The idea that in the 80s, IBM came up with the idea, which actually was kind of the seeds for what happened with Agile Agile down the road. And it also happened with, DevOps and DevSecOps and modern day techniques we use today for things like microservices and whatnot, which was, instead of these giant monolithic releases, let's go ahead and let's do more rapid development by producing small reusable components. And then on top of that, let's make smaller releases that focus more on, just what matters, right? So releasing smaller features more rapidly. And that kind of led into Agiles, right? In the late 1990s and early 2000s, smaller releases, faster releases, more collaboration. That was actually one of the key components of Agile. Was suddenly, you did scrums and you have a scrum master and all these kind of things, and it's great, right? This is just the way software development has been over time. And with software development was, we were happy, everybody was good. My job was to go ahead and code and do the coding things that I do. And, life was just what it is, right? Operations, the way things were hosted, if it was a web thing, like my first product, the one from that picture, by the way, we were the first web-based CRM product, right? This is before, Salesforce. This was before everything else. We were the first. And the thing is, you had to think about these things, but you had separate teams that handled all these things. And the thing is, we've had so many different schools of discipline over time that really, the thing is that it's all been an evolution. You learn from your mistakes in the past. You move forward to kind of bring, what you've learned and remove the hindrances. But the thing that really changed everything was this thing, which, Amazon CTO came out and says, you build it, you run it. This was the fire that really lit the whole idea of DevOps, right? And yes, it was a great idea. Suddenly there was this idea of, yes, we could do more. And you know what, this is where things got complicated. This is where things started to get complicated. And one of the reasons why platform engineering is kind of coming about right now, and we'll discuss it. While DevOps, and we are a DevOps company, and I would actually say that DevOps itself is not really where you should look, but it should be DevSecOps, right? Security should be at least part of this. But DevOps started off, the idea, we all know the infinite loop, right? And this infinite loop, by the way, is still the same thing that goes all the way back to the waterfall method too, right? You plan, you code, you build, you test, you release, you operate, you monitor. The thing is with this is it became more ubiquitous. It became more seamless for companies to do this. This was the idea. It was more exposure, more information on, and if provided, and to be able to operate faster, right? To become more efficient in the things that you do. Like I said, once again, smaller, more precise releases. You focus on fixes from the previous release, and you also work on some potentially smaller new features. You usually don't hold off the grander features till maybe later. But then, of course, security came about and was like, hey, what do? We should be part of this too, meow. If you've ever watched Super Troopers, that's my little joke for the day. Thank you very much. I'll be here all the week. But the idea here is security wanted to be part of this. And you know what? They had every right to be. The thing is that I give talks on this all the time. With software development life cycles increasing, we've also seen a huge influx in the number of potential malicious and nefarious components brought into the software life cycle, right? The software supply chain. We actually refer to ourselves as the software supply chain platform. And the reason why is we maintain and monitor all those third-party transitive dependencies, both implicit that you state for your code and all the transitive friends that come along with it, right? And remember, 85 to 90% of the things that you build are someone else's code you don't know. But we also maintain and manage the actual builds you produce. Throughout this entire cycle, you need to encourage your teams to incorporate security. Everything from shift left by providing your developers with all the appropriate tools. I'll show off some today. And like I said, we'll be at RSA next week. Through your CI process, your continuous integration process, and all the way now to your CD, the continuous delivery. This really is what DevOps and DevSecOps, the dream, that was being proposed came to the table, right? This is what it was all about. Smaller releases, faster releases. Also, as part of this, the idea also came about is you need to also learn things. There's a lot of things out you need to learn. And, everything from now, not only do I need to know the language I need to do my job, I might be using Rust, I might be using NPM if I'm doing web, I might use C and C++, whatever I'm using to solve the problems that my product is trying to solve. Now I also have to think about things as how do I operate a Docker image? How do I build the Docker image to make sure it has all the proper components for it? Is the base image I'm using safe and secure, right? Because I have no idea where this image is coming from. I have to make sure that I help with the CI process. I have to work hand in hand with my QA team to make sure I'm providing all the proper maybe hooks into for QA testing. There's a lot of cognitive information I need to learn as a developer now. The time when I was a developer and I had to run my system, I relied on build engineers. I relied on release engineers. I relied on QA engineers. I relied on security engineers, right? There was a lot of delegation of duties that were done through the organization. And there's still a lot of organizations that are trying to adopt this method of maybe consolidating and actually more collaboration, and also choose cross-team dependency trainings, right? So as an engineer, I need to be aware of safety precautions. I need to be aware of how things are being implemented to be deployed, right? These are things I didn't really sign up for. This is actually one of the biggest complaints with most developers these days, is all the other things they need to learn to get their job done, instead of just concentrating on building out certain things like the code I do, especially more in smaller organizations where there is less delegation of duty. In larger organizations, there's still a lot of organizations out there that still have these separation of duties between them. And saying that, the thing is that, let's talk about the reality of software development in the DevOps world, right? So first of all, the explosion of artifacts, right? This is a huge thing. This is actually one of the reasons why we are here, JFrog, as a company, right? We manage the artifacts, Artifactory. That's its huge, its thing. And over time, because of the number of releases that companies are doing, have become more frequent as opposed to the monolithic days when I started. Like I said, it was really interesting, being part of this from the, as a low-level software engineer coder when I started, worked my way all the way up to a couple of different positions, have my own startups, I've had a couple of acquisitions, and I've built lots of products over time. So I've been there for the evolution of software development. It's not just software development, but it was, the inception of DevOps, doing things better, more efficiently, seeing all the crap that's happened over time and how can we make it better. And saying that also, too, means that when we look at this is from an article that I read, and I thought it was really, really interesting. It's like in the 2000s, my developer responsibility, you can see in the middle, was code, right? In 2005, just as things started to come about, when, suddenly we started looking at things like, how do we, do things more effectively? We start, and I'll tell you, my company that I was part of in 2005, we started doing this too, which is not only do I have to code, now I got to figure out a way to package and ship it, but it really wasn't as predominant. Mostly it was jar files to do things like installation. It was Java-based stuff. It's a web sphere, and I had to understand like all the components I needed to make sure that when I deployed it into WebSphere, that I had all the operational components done. And then in 2006, like I said, an Amazon CTO came out and said, you build it, you run it. Now suddenly, not only do I have to understand how the code works, but I also have to understand how things work below it. And before we had Kubernetes and all that, we had Heroku and some other ones that were out there. They were like, Docker was, was starting to come about, was, like this whole idea. This is also a couple of years around this time period, 12-factor, which is my favorite methodology on how to do development, which is, basically make sure that the development environment that you use is the same kind of infrastructure you would use in production. So like on my Mac, even to this day, when I still do all my examples, it's hard pressed in my head that I have my IDE, all my code is local on my disk, but I'm using an Ubuntu container to actually go ahead and operationalize all the things that I'm doing, because a lot of the tools work more natively in my Ubuntu image. And it's also just become a habit. And then we got to like 2015, Kubernetes and all that started to come about. We got this ideas of like infrastructure as code started to come about, Chef and others. We evolved with that, by the way. Our platform has evolved with the changes of the time. And this has been really exciting. And now we've gotten to the point where now coders have to think about full lifecycle management. Like not only am I coding it, but now I'm going to have to figure out how to make it, how to ship it, how to run it, et cetera, et cetera, et cetera. And, now I've got a whole bunch of things I need to learn. Microservices were one thing, but now microservices and other stuff, like I said, like suddenly I have to learn Terraform or Chef or Ansible can really make it hard, and there's a lot of learning. And don't get me wrong, I mean, if you're like me, I got into this industry because I wanted to learn, and I loved it. I didn't want to be in a stagnation of a job. I wanted it to be something I knew was going to be perpetual. It was going to be constantly evolving and constantly going. And I still get excited looking at all these new technologies. Like my latest obsession is Rust. I'm obsessed with Rust lately. That's a whole nother webinar that I'll be doing soon. But I love some of the concepts behind it. And like I said, this is new things, but at the same time, there's a whole nother side that I used to delegate to other teams that would do this for me. And if you look nowadays, there's so many tools in the world that have specific things for everything, right? I mean, there's tools for everything, from life cycle management of things like Jira ticketing systems. We have communications, like real-time communications have now become more precedent with like Slack and MS Teams, integrating it to your CI/CD DevOps workflow. Of course, you got like things like VCS, the multitude of build systems out there, testing systems, deployments, and runtimes. I mean, come on, look at this. The thing is that it's completely insane and overwhelming sometimes when you're looking at this. And as we move from job to job and position to position, or teams evolved inside of companies, whatever it is, the thing is that we're always looking to make things more effective and more efficient. And sometimes that means bringing on things like new tools. And that can be really overwhelming in a lot of cases, right? Especially if you have tight timelines and stuff. So now, if I need to go in and learn, say, I'm going to start using Terraform for all my infrastructure as code, which has actually become a huge thing for most companies, right? And it makes sense. I love Terraform. I love Chef. I love these tools with the idea of configuration as code. Awesome stuff. I mean, think about this. It's where the times have come. And especially, like I said, I'm an old gray-haired dude. You can take what you want out of it. But the thing, like I said, a lot of these things and these pings I used to feel, the fact that people have recognized this and created tools over time to help simplify it is awesome. But that's going to take time and effort. You're going to have to invest in yourself, and your company's going to have to invest in your people to learn this. So that means also to expenditures. You're going to have to take time off of development cycles possibly to learn lots of different things that we've learned over time. So when we talk about this, there's a lot of problems with DevOps, right? And I'm a huge DevOps person. I love DevOps. I still believe in DevOps. That has not changed. This is not that talk, but this is an evolution. So number one, most of the time, DevOps is approached with a lack of definition. Let's face it, right? It really, truly is. We're going to automate this. How are we going to do it? We really need to just focus on the features and get the product out there. Let's go in and let's do what's necessary. Right? It's not like what's best most of the time, it's what's necessary. It also creates like a false dichotomy internally, right? So there's blurred lines of basically these blurred lines on like what really is automated, what's not, and there's a lot of messes. On top of that too, a lot of companies don't sit down and write a charter when they start going at things like DevOps, right? They don't sit around and say, okay, here's our guidelines. And usually if they do, it's usually specific to a single team. In most cases, that's not the case. Remember, I showed all these tool sets, right, in the previous example. Doesn't mean that every software division, every software team in my company is going to be using the same thing. Sometimes the tools don't apply to the usage of what you're trying to solve, right? The thing is that some take specific things that they might need to use. You might need specific CI systems that can handle it. It might be specific CDs. You might be, and the thing is, each team can have its own set. And the thing is that these guidelines might be for a specific team, not holistically for an entire company. This causes dissonance, especially sometimes you get a cross team like sharing where one guy will come over to another. One team uses Jenkins, another team uses GitHub Actions, another team might use something like Azure DevOps. One team might be checking their source code into GitHub and another one's a Bitbucket. We see this all the time. And that's the thing is that the problem is that each one of these is the problem with ownership too. It's just like things were taken on just to accomplish the job and get the job done. Larger companies have a harder time with this, especially because sometimes there's divisions. Smaller companies are a little more adept, but at the same time at this, true DevOps adoption, especially in larger corporations, is pretty low, right? It's like, they're all getting there. There's like this whole report you see 85 to 90% of the companies are heading to this by 2025 and all that. trust me, we talk with a lot of companies all the time, and I've heard it all. And I'll tell you, there are some that are true DevOps, and they've gone, yep, we are doing GitOps style. We're checking in our code. We're automating our builds. We're automating the QA testing. We've automated everything out the door, and we're good. I have other ones that are like, well, we still use a bunch of legacy applications that can't be ported over the amount of time. Like I said, it really depends on the organization. And this is something you need to keep in mind when you are discussing this with your organization internally. And there's some common mistakes, right? Speed versus quality. Just because you're releasing faster doesn't mean you're actually producing quality components, right? There are times you need self-reflection and evaluation when doing this. Also, too, a lot of times they don't focus on the people. They focus on the process, right? This, and this. And this is how we're doing it. Give it to the developers. This is how we're doing it. Go ahead and do what you need to do. Another thing, too, is unrealistic goals. We hear this all the time. We want to be, we want to climb to the top of the mountain, and this is our goal, and it's amazing. This is like the pinnacle of DevOps. Well, you know what? There's a series of base camps that you need to do to get acclimated before you get to the top. And I'll tell you, a lot of companies have this grandiose idea, and they stop off around base camp too, right? They're like, you know what? This is just good enough. Another problem is inflexibility. You would be surprised. Like, the thing is that I'm sure actually maybe some of you have actually been aware of this, but some of these systems are set in stone. They're like, this is the way it is, and that you just have to work within your confines inside the guidelines that have been defined by somebody. Another one is, you know what? We spend a lot of time with our SREs monitoring like reliability or slows for service level objectives, right? We monitor all these things operationally, but we really don't monitor the velocity of an organization. Utilizing tools like, if you use Artifactory in our X-ray product, you can use tools like Splunk, Datadog, whatever, to monitor. And with the information there, you can actually gauge a team's velocity. How effective and efficient are we at developing our software? And the thing is that, the entire SDLC, the software development lifecycle, if you use Artifactory and you design your repositories correctly, you have dev, QA, staging, production, and you're promoting through, you can literally query those repositories and say, I produced 100 builds on this last sprint, and I put it into dev. Out of those, we had one production build. How many made it to QA and failed? How many made it to staging and we did one last check and it failed? How are we doing in terms of attempting to fix things like security vulnerabilities? I mean, you can connect our X-ray product all the way into tools like Splunk, Datadog, and others to also say, how are we doing in addressing any potential nefarious components, malicious components that might affect us and hurt us as a company? Reputation, financially, even releases, which also goes back to reputation, financially, right? The problem is that there's a lot of people out there, and when they look at this, you got to look at every step you do when you're working with DevOps as a pebble in the pond, right? You put the pebble in, it expands, you look at centric rings, it's going to affect a lot of things. So the other part of this too is also legacy development versus new development, right? The idea of hybrid DevOps. This is another thing too. How do you actually go ahead and attribute to things like legacy builds that may not fit the DevOps mold and new ones, so that you can have some sort of layer of symbiosis between those orgs internally? It's tough, right? We see this a lot, especially like equipment manufacturers and others. And the other thing too is, and this blows my mind all the time, is a lot of times a lack of security protection, right? Once again, delegation of duties, this whole idea, there's a security team, and that security team has its say, and they need to, but they should be part of the process too. And in a lot of cases, they're treated as a separate entity, where I'm going to talk about today is they need to be part of the discussion. They need to be part of every piece of this from end to end, not just a bunch of people coming to you saying, you introduced this and you're a bad person. So what is platform engineering? Thank you for your time on that one. Let's go dive into it. Now, I did this as a joke, right? So the idea of platform engineering being, killing off DevOps is not the case. Think about it as a addition, right? Or a refinement, actually, that's a better way to say it, of DevOps, right? It's really still DevOps. This hasn't changed, but there are some core capabilities here, which is basically design the actual, build environment, design your build system to be self-service, workflow capable, right? And also to make it for the software developers and the development teams and any ancillary people that are associated to this, right? It's not just, it's a consolidation. And we'll talk about that, right? It's a consolidation of tools to make things easier, processes, procedures, and whatnot. It really, what it comes down to is taking DevOps, which was a beautiful concept, still is a great concept, but at the same time, looking at its problems. Remember, DevOps is inflexible, right? And I'll tell you, there are zealots of the DevOps world that would disagree with me on everything I said about what I'm about to say, right? But at the same time, once again, we're in software. Software is an evolution of what we do. And it's actually the inherent model of software development is evolution, right? Constantly evolving, constantly changing those things. So when we talk about it, the first key component you need to talk about is something called like an internal developer platform. And I'm going to talk to you on how to get there, right? We're going to talk about how to get there coming up soon, but I want you to understand, which was one of the key components, which is self-service. I love this concept. I love this idea. And when we talk about self-service, it's very secular, right? It's very much like the infinite cycle that you would see, but in this case, it's more of a circle, right? You have a software development team on your left, you have a production team on your right. If you were to think about it this way, it'd be dev, QA, staging, and production. Your developers can go ahead and you need to provide them with a portal that could be a combination of tool sets, instructions, links, right? A common base for everybody to use, best practices, whatnot. It's a central location for every developer to go to and get references. This also can include things like, like information you might get from some monitoring tools. The next step of this is, of course, your DevOps pipelines up here to the, up here on the top left. And the idea here is that consolidation that you would instantiate, utilizing, the stuff from the catalog. Maybe you have a standardized build system. Well, this is how you deploy it. Here's some sample templates on what you want to do. How do you manage your environment, right? Also, too, maybe some cognitive information provided to these developers where they can see things like the current state of the environment or what tools are available or any updates that might be coming based on your other teams. Of course, there's also compliance and automation. So in other words, you can also have your checks and balances around things such as security, license governance, and everything before you develop it in the production. It should be, definitely a compliance component behind it. Of course, there's infrastructure and configuration management. You need to, these are all the components that are available, but they need to be actually presented to the developer so they're not fishing around and trying to find things. And then lastly, one of the biggest things here, especially in this day and age of recession, I said the word recession, but the market is tough right now. There's a lot going on in the market, so you also need to have a budget and cost governance monitoring area, right? Are you exceeding? Are you your cloud expenditures, right? You need to know what your budget is, and these are things the developers need to know about too, but in a way that is not so much in their face, but more informational. And this is where an internal developer platform could come. You should consolidate that information. Like I said, uptimes, compliance and automation rules, what infrastructure are they using? Are there templates that I need to know around this? Then, of course, the big thing is reduction of cognitive load. What is cognitive load? Well, that massive list of tools that I sent you? Yeah, that's what cognitive load is. The thing is that we have to learn more and more and more all the time. And also, too, there's a lot of things that if I'm trying to build a feature in my product and suddenly I've got to go ahead and learn how to do infrastructure as code, but I got to teach myself how to do it, that might take away from my ability to meet my KPIs and stuff within that sprint. And the idea here is that we can only have so much. Like I was going to use an old 90s reference called Johnny Mnemonic with Keanu Reeves, where the guy's he's got an 80 gigabyte drive in his head and he needs more space, so he pumps it up to get more information in. We have a finite number of stuff that we can learn in a way, especially around this, without it detracting from our other responsibilities and roles. So the other part of this too is, remember, keep cost in mind. A lot of it is like things you need to keep in mind. Human capital, right? How many developers do I have? What's the cost per team per hour, right? Are there other teams? Is it going to take me time to train people to use things? There's all the human capital side. Also, too, on processes and tools, like how many tools are your teams using? These are things you need to start auditing. Are you using one CI environment for everybody, or is there 100 CI environments? What's the total cost of ownership to maintain these tools? What's the operational cost? Like, are you doing something where you're building ephemeral Jenkins servers that build all the time, and you think this is great because we're just building them and tearing them down, but you're using amazing amounts of resources that might cost more? That's also the capital cost. Like, how much capital have you actually invested into this? And the other big one is, are you really using these tools correctly? You would be surprised how many people who use Artifactory or use our platform, they'll come to us and ask us for advice. We're like, well, you're actually not using it correctly, even though we supplied them with our academy to do their job. Also, hosting, right? And production costs. Is there a way to make it more efficient? Is there a way to make it more effective? And then lastly, too, security. Where is your security begin? Is it shift left where the ROI is greatest, right? So if you are actually doing it at the developer level, we have like ID plugins and stuff that we offer for JFrog, right? We have the building, the CI. We could pre-evaluate those third-party transitive dependencies before they get into the developer's hands. On top of that, too, we also have other things, that you can kind of use for that to make sure it's better. Also, being able to promote based on security vulnerabilities is huge, right? Do you want to really put something in production that could potentially have a huge loss to your company? Well, how do you adapt and evolve, right, to do this? So the thing is, you got to keep in mind, first of all, design this. It's yours. You own this. This is to make your life easier, to make yourself happier. Also, too, do what's best for your teams, right? Look at it, evaluate it, but not only your team, but other teams too, right? You're not in this alone. There might be collaboration. One of the big things about platform engineering is collaboration. People get together, right? You designate people from each one of the segments of teams: security, operations, development, and whatnot. Also, too, think of it as a product, right? It really is a product. You are not reinventing the wheel. What you're doing is you're doing a consolidation of components to make it more streamlined, to make it easier. Really take time to look at this and evaluate what you're doing. And the thing is that, key considerations to keep in mind, internal customers, right? Deployment teams, finance, security, it's everybody, right? There's a lot of people involved. There's a very myopic view that companies have when it comes to developers, but it's everything else that's involved, right? You need to have organization goals. Not only you, but also everybody, all the other pieces, everybody that's included in the life cycle, even down to product people, right? You need to make sure it's targeted, make sure it's reusable, scalable, all the usual stuff that you're expecting. You're also looking for, what's the desired outcome at the end of this, right? Is the provisioning, is it effective? Is it efficient? Is it really meeting your needs? And are you following things like best practices? You need to design things. You need to make it declarable and extensible, right? Once again, a lot of companies implement DevOps and they keep it very, very locked down. It should be an evolution. So the other thing too is that you should be constantly evaluating this to figure out, can we reduce cost? Can we reduce complexity? What kind of things can we do as an organization to make us better? And the thing is that when you are developing as your teams and you are starting to look at this, these are things you need to keep in mind, right? First of all, you need to treat your internal customers like customers. Your developers, your operations people, treat them, query them, right? Interview and audit, identify what tool parts are necessary, right? Look at the pain points, look for processes and approvals that might be hindering, right? Design around self-service, right? If there's anything manual, can it be actually automated? Collaborate with all the common factors that you might have. Look at your bottlenecks, right? Your development, your languages. So always include development, QA, production managers, team leads, SREs, release managers, right? These are people that are, this affects them. If you're doing this more effectively, your product managers are going to be happy. Your release managers are going to say, wow, you guys are really pumping stuff out there. Your site reliability engineers will be sitting there looking and going, wow, okay, you know what? We're actually seeing a better efficiency in not only the way we're deploying it, but actually the uptimes that we're doing, right? There's a lot of people involved in this. Don't have that very singular approach that your team is unique as, and you're part of a bigger ecosystem. So understanding that, you need to start defining the platform of your dreams, right? How are you going to create the self portal? Look at how many developers you have and the locations they have, because you might have more global aspects. How are you handling things like version control, tools, developer workflows, security concerns? all these pieces here, you need to think of the entire life cycle, not just a single piece behind it, right? Make sure that you have everything that covers what it needs to be. Look at the tool sets. Make sure when you're evaluating the tool sets that when you're doing this, you need to make sure, is the version control work for all use cases? If not, there might be some corner cases. Is there standardized IDE? APIs is a big thing. When you're looking at your products, always look at the APIs, and because that allow you to integrate and do things like our platform. We have super extensible APIs for every piece of what we do, and that's on purpose because no two companies are the same, but they can utilize our APIs to help leverage what they do, right? Ticketing, communications, right? Active live communications with information from the system could be the difference between, a complete down outage, down to, is there a vulnerability, things like that. There's a lot of stuff, right? Artifact storage, of course I'm going to say that because we're JFrog, Artifactory, and accountability and liability and auditability is huge. It cannot be discounted. I mean, I show an example all the time of, I always ask my customers, show me the application layer in your Docker app and tell me between these versions of your Docker app, what changed. You can do that with us, right? That's a bonus. The amount of time I'm saving you by providing you with information is tremendous. Also, too, deployment technologies, automation, security tools, right? Look at all the pieces and figure out where you can consolidate and things like that. Now, saying that, you're going to want to go ahead and build this new platform, right? And the first thing you're going to do is design it, right? This is actually, once again, treat your internal systems like a product, right? I said that in the previous step. And the thing is, number one, use goals. What is your goal, right? And they can be aspirational. You should also go ahead and make interim goals, right? Assign leads from each team to make sure that you have a small governance body, not a huge one. There's a lot of chatter. Always find people who represent the people that work with you. Use more of the 80-20 rule, right? 20% of your effort will actually yield 80% of the results. So always keep that in mind. Do smaller releases when you're doing it. Also incorporate things that you are using as this all the time and constantly adjust. Right? Adjust it. It's okay. This is not written in stone because when you go ahead and you deploy it to the next piece, right, you're going to go ahead and make sure it covers your use cases and issues. Create automations where automations can be created. Use a test team, right? Test this. Make sure that it meets all your stuff. Don't build it all at once. Do it in smaller chunks. Iterate through it, right? Treat it like an MVP, right? Treat it as a product. I can't iterate this enough. And then take it to the next step, right? Which is, also to validate it. Make sure you're gathering feedback constantly. As you're deploying this, make sure you have somewhere people can actually go in and put in, issues and suggestions and whatnot. Make sure you're always testing the scenarios again. Identify those issues. Make sure the expectations are being met. Once again, you're interviewing your teams. It's a constant thing. By making this an evolution as opposed to a stringent method, this allows you to have a lot more flexibility, right? You don't get locked into something, you're doing a job just because you're doing the job. This gives you the ability to adjust it at any point. And then lastly, of course, treat it like any other software project. Start over and improve, right? So this is this constant repeat cycle. You will find it better in the long term to do this because this will allow you to constantly go in and make it better and better. Treat it as an evolution. So the last part I want to bring up here is, of course, this is our talk, right? And if you look at the platform and what we're doing, we are a solid base foundation for platform engineering, right? We are the secure software supply chain platform. We incorporate everything from security to the artifact management, to release management, to the distribution side. If we start on the left-hand side, of course, Artifactory, the universal binary repository manager, our big, long description of what we do. But we manage the 85 to 90% of stuff that you consume to do your job, and also the builds you produce, and also a way for you to have that software development lifecycle. We also give you the better approach of accountability, auditability, things like, being able to go ahead and automate more because of a massive amount of metadata that we provide. I have tons and tons of examples. Like I have an example here I'm working on, and this one here, I'm actually using a Jenkins job that I built, but I'm actually using querying of metadata and properties to go ahead and automate the build task I'm doing to get the latest version of an application put into a Docker image, right? I don't have to go in and even in this example here, I'm also doing another segment where I'm creating a Helm chart to deploy that Docker image. This is a 7-step web example that I'm using metadata in the system to, even in this case, go ahead and actually update the actual values.yaml for a Kubernetes deployment based on metadata on the images I'm going to deploy. I'm able to automate these steps. This will save me time, effort, and money. And this is stuff that's actually baked in to what we're doing, with the platform. Of course, I mentioned the fact that, security, right? So all those binaries that you're utilizing, those third-party transitive dependencies, both implicit or direct, and also all the ancillary ones that come along with it, right? Everybody knows about NPM. This makes sure that it's safe and secure. And the thing is, we are a CNA. We are a CVE number authority. We speak with authority on this. We are producing CVEs all the time. But we have a layer of protection to pre-evaluate binaries, those third-party transitive dependencies before they get into your developer's hands or the tool's hands. We have ID plugins. This is one of my favorite things to show companies lately is this. Here we go. Here's an example of an NPM project I'm working on. We're able to recognize any of the CVEs that are available. And then as a developer, I can go in and actually, go ahead and actually fix it. And if you look here, we even tell you, are you being affected by an issue with a third-party transitive dependency? You can see this is applicable here. We actually tell you where it's happening. And if I click on this little segment, I can actually show you, here's the actual file, and this happens to be my authentication, and I'm able to go in and address it directly. One of the biggest hindrances for companies these days is addressing those issues. And the thing is that where we've actually had our highest benefit with a lot of our customers is this. I'll show it to you quickly, is that we introduced our new advanced security feature lately. And one of the nice features of our advanced security is that ability for you to go in and actually, I'll just show you, which is, we see customers all the time. There was actually a 650% increase in supply chain attacks in 2021 alone, and it increased in 2022. But I ask every company, and I go, you know what? You need to have security as one of the paramount things that you do. And in this case, I have a Docker image I need to deploy into production. And I ask every company this. I have 287 vulnerabilities. How long would it take you to go in and research and fix all 287 vulnerabilities? Most of the time, there's no answer because it's daunting. Yes, you can address them where it matters most at the JFrog CLI and also our IDE. But with our new contextual analysis, I'm able to tell companies with authority that actually, here's the thing, is that 287 out of these, 74% of these is actually not applicable to them, right? It's not applicable to them. And I can also go ahead and even show other ones that are applicable, right? This gives me the ability to go in and do this much faster. Then we have distribution, right? So when you think about our stuff, we have distribution in 2 different models. We have our distribution, which is like a hub and spoke. This allows you to use our Artifactory edge nodes, or lightweight immutable versions. But this allows you to deploy your stuff in your own cloud, your own data center, cross-cloud providers, right? We're agnostic in that respect, but this gives you the ability to go in, deploy web services, deploy updates to vehicles. We have a lot of car manufacturers, that use this to actually update their vehicles and do that. We also can do it to different regional clouds and things. And then we have Connect, which is our IoT platform, allows you to do device updates, remote diagnostics, and things like that. And then we have our JFrog Pipelines product. It's our CI, CD, and CI orchestration. You can use it as your own CI and use it as a standard across. You could also use it as a CD to distribute your software if you've already invested in your CI. Or remember we talked about consolidation of tools. You can use our pipelines as an endpoint. And in other words, you can actually go ahead, and if I show you our pipelines product here, one of the things I always love to show whenever I show off the pipelines product is I have a whole bunch of jobs here. And if you use this as an endpoint for other jobs, we can actually show you how jobs are interdependently connected to each other. And since the idea of consolidation is truly what platform engineering is, well, if you look, here's Artifactory, here's X-Ray, here's our distribution, here's our pipelines. This is end-to-end SDLC in one place. And we also give you the ability for you to go in and look at all the things that you're doing. And on top of that, really, it's all API-able, it's all scalable. And the other part of this is that it's also replication and whatnot, so you can be a global entity with diverse teams, and this gives you the ability to do that too. But also too, when you do face issues, and you will face issues, everybody does, I can go in and also too trace all the things that I'm using through their entire life cycle, from their inception and when they pulled them out from the public, all the way down to every place they're being utilized, and also give the ability to do faster remediation. And on top of that, do it at a global scale. So I will leave some time for some questions if anybody has any questions right here. But I want to say before I sign off, and we do this, if there's no questions, I just want to thank everybody for coming today. But like I said, it doesn't have to be overwhelming. There's things you could do as an organization, and there are solutions out there. Of course, I highlighted our solution because this is our webinar, but also too, keep that in mind. You know what? This is a systemic problem. If you want to operate faster, be more safe and secure, there are plenty of things to do out there. I hope this has been helpful. I will wait for a couple of questions. And if you have any other questions, let me know. I'll be at RSA next week. So if anybody's going to be there, I'll be there the whole week. If anyone wants to sit down and talk and chit chat, I am always down for that. But I appreciate you taking time out of your day. I know everybody's busy. So thank you.
And thank you, Bill, for hosting this amazing session. We have a couple of questions online. One is about how does platform engineering work with distributed teams versus centralized teams?
Excellent. That's always a question I get when people ask us about our platform. And actually, it's funny is right here with us. That's the thing is that one of the reasons why people have chosen our platform. Like I said, we have like almost, we're heading towards 100% of the Fortune 100, top 10 banks, and all these kind of things. The thing is that with this, the idea is you can have Artifactory and we have replication, right? Distributed teams, especially during the pandemic, exploded, and our product has been doing this for over a decade, right? The idea is simple. Getting able to have that consistency across organizations, no matter where they are, is what we do. We have plenty of talks on this online for us, but in general, this has to be a consideration, right? Global distributed teams is a thing. It's been like this for a long time, since outsourcing started, and now teams, especially during the pandemic, I've seen so many teams that are out there that have their developers are everywhere, because during that time period, everybody went everywhere instead. But there's ways to do this. We have tons of this. We will actually, tons of this information online on how we do it, but this is a consideration. Like I said, geolocation is very important. Any other questions?
We have another question more like on the environment side. It's like, does platform engineering necessitate like going with a SaaS solution, or can we use like a self-hosted for platform engineering?
It depends on your usage, on the company. I mean, if you're a regulated environment, most of the time you're going to have to either host it yourself or host it in some sort of secure location. It depends. That's actually a discussion that we see a lot of companies having these days, right? The idea of reduction of like total cost of ownership, TCO, or operational and operational costs and capital costs by moving to a managed solution. We have I don't like saying SaaS or in a lot of cases for us, because we're more than that. We're more of a managed solution. You choose your cloud provider, your own regions and whatnot. But the idea is this is a discussion you need to have with your team and your executive staff and your budgeting people. This has become, we hear a lot. We actually have a blog post that's coming out, or it came out, I can't remember, called tools consolidation, right? This is what we see. We see a lot of companies moving to the cloud. We see a lot of tools consolidation. And by the way, tools consolidation is just another word for platform engineering, really, what it comes down to, right? Do more with less.
Thank you. And I think we have one last question so far. And the question is like, do you find in your experience that there is an optimal number of tool set for developers?
That's an impossible task, unfortunately. Problem is that there are corner cases that always happens, we know, that are out there. You try to do an optimal number, but it really depends. Depends on what you're building, depends on the industry, depends on regulations, depends on lots of things. No, there really isn't. But if you can, certain things, like I'm going to talk about us, right? I mean, we're considered like a great base foundation for all of this, right? We actually have, you don't have to use all our tools, but if you use Artifactory and X-Ray, just that with our distribution, you have an amazing base level. I always say, picture us as being the conveyor belt when you're doing this, right? You might change the tool sets you use over time to manufacture your products, but the conveyor belt might stay the same. And that's what we provide, that consistency. The raw materials come in and the product goes out. We're there through the entire cycle, collecting as much information about it as possible, making sure that it's not, it doesn't contain anything harmful, and we send it out the door. But those tool sets that assemble it could change and evolve and become more efficient, or they can reduce and become more streamlined. So, like I said, there's really no one-stop shop for any of this.
And thanks again. And I think that's all for the questions today. And thank you, Bill, for hosting the session. Thank you for attending the session. And if you have any last-minute questions, feel free to email us at webinars@jfrog.com. And we'll be answering in the next hour, and I can forward that directly to Bill. Thanks again, and we will send the recording pretty soon, and we look forward to seeing you online soon.
Thank you guys so much. Be safe, be wonderful, be well, everybody. Take care. Cheers.